So you all had understood about these things, all the different points which are related over here. Now we will move to the next part, where we are going to see, or where we are going to observe that we are going to classify the mirrors into two basic forms. जब हम लोग कॉनकेव और कॉनकेव मिरर्स को पढ़ते हैं तो हम लोग उनको एक और नाम से भी जानते हैं, which is called to be as the converging mirror and diverging mirror. Concave और convex mirrors को converging mirrors और diverging mirrors के नाम से भी जाना जाता है. So why it is so? It is because of a basic principle related to this one, that when we are discussing about the kind of the image which is present over there, or the light ray which is going to reflect back from that one, that how it reflects back, on the basis of that we can classify them into it. Okay, so concave mirrors are as convex mirrors, and convex mirrors as a diverging mirror. Now let's continue and understand that how this used to be there. Or why do we observe as a concave mirror as a converging mirror and a convex mirror as a diverging mirror. तो देखो यहाँ पर जब हम लोग concave mirrors में देखते हैं तो concave mirrors में एक phenomena होता है कि all the light rays which are coming parallel to the principal axis, they all gets reflected back through the focus of the mirror. ये एक principle है जिसको कि हम लोग आगे अभी image formation के principle के रूप में भी समझेंगे, लेकिन फिलहाल अभी इसको देखते हैं तो कि जो भी लाइट रे पैरेलल आएंगी प्रिंसिपल एक्सिस के, they all will reflect back through the focus. This is the basic rule which we have to remember for a concave mirror. And because of this nature, or because of this phenomenon, or because of this condition, we do observe that the image which is going to form over here, that will be real. We will see it further on. But here, as we are classifying that concave mirrors as a converging mirror, it is because all the light rays which are coming parallel to the principal axis, they get reflect back through the focus. So over here the focus used to be there and it crosses through this. तो जितने भी light ray parallel आती है principal axis से, वो जब reflect करेंगी तो वो focus से ही होके करेंगी. This is of sure. Okay. And the next one is that if we observe for a convex mirror, अगर हम लोग कॉन्वेक्स मिरर में देखते हैं तो यहीं पर ये वाला फेनोमेना थोड़ा सा चेंज हो जाता है. तो यहाँ पर हम लोगों को देखने को मिलता है कि जब लाइट रेज पैरेलल आती है प्रिंसिपल एक्सिस के, देन दैट यूज्ड टू डाइवर्ज, वो दूसरे तरफ वो डाइवर्ज हो जाती है. जस्ट अ मिनट, आई विल यूज दैट. तो ये इस तरह से डाइवर्ज हो जाती है, वो दूसरे तरफ डाइवर्ज हो जाती है. तो जितने भी लाइट रेज पैरेलल आएंगे प्रिंसिपल एक्सिस से, वो दूसरे तरफ डाइवर्ज हो जाती है. We are producing it to this side. If we are producing it further, then we will observe, or we will say that the image is going to form at the back side, that we will see later on. But over here, they appears to meet at the back side. So as the light rays gets deviated, or it gets diverged to the other side, that's why we say this, that convex mirrors are the diverging mirrors, whereas concave mirrors are known to be as a converging mirrors. तो प्लीज इसको याद रखना है, दोनों चीजों को याद रखना है. पहला चीज जो तुम लोगों को इसका नाम याद रखना है कि concave mirrors are known as converging mirrors and convex mirrors are known as a diverging mirror. सेकेंड चीज तुम लोगों को ये भी याद रखना है कि what is the reason behind that, why do this happens. So a concave mirror is called a converging mirror because all the light rays which are coming parallel to the principal axis gets converged to the point focus. So you can see over here, तो यहाँ पे देखोगे कि ये converge हो जाता है, ये आकर यहाँ पर मीट करती है. जो भी लाइट पैरेलल आ रही है प्रिंसिपल एक्सिस के, वो कॉन्वर्ज हो रही है. जबकि दूसरे तरफ अगर हम लोग देखते हैं कॉन्वेक्स मिरर जो है वो डाइवर्जिंग मिरर कहलाता है, क्योंकि ऑल द लाइट रेज व्हिच आर कमिंग पैरेलल टू द प्रिंसिपल एक्सिस, दे गेट डाइवर्ज टू द अदर साइड and they appear to meet at the back side. As I said earlier that I will share a link with you all for another video. In that one I had used an animation to show the conversion condition and divergent condition over here, so you all can go through that one. I will put that video in the I link at the top. You can see through that one. Okay, now let's move to the next thing which we have to understand over here, that is the rule for the image formation. देखो स्टूडेंट्स, बुक में जो तुम लोगों के पास इमेज फॉर्मेशंस दी हुई हैं, अलग अलग इमेज फॉर्मेशंस जो स्फेरिकल मिरर्स के लिए दिया हुआ है, उसको बनाने के लिए या उसको समझने के लिए हम लोगों को रूल्स समझने की जरूरत है। अगर हम लोग रूल्स नहीं समझेंगे, अगर हम लोगों को रूल्स पता नहीं होगा, तो हम लोग इमेजेस नहीं बना सकते हैं। सो रूल्स आर वेरी वेरी इंपॉर्टेंट फॉर द फॉर्मेशन ऑफ द images. So these are the four basic rules which you need to remember. So I had made the concave and convex mirrors both together over here, so that it will be easy for you to identify the rules and remember the rules. Okay, so बस ध्यान से याद रखना है कि किस लाइट रे का पाथ किधर से जाता है, और बस इसी से तुम लोगों की इमेजेस भी बन जाएंगे। ठीक है, so let's go for the first condition, that is for the concave and convex. For the first rule, which states that the light ray which is coming parallel to the principal axis, तो लाइट रे अगर पैरेलल आती है प्रिंसिपल एक्सिस से तो क्या होगा? तो अगर कॉन्केव में वो पैरेलल आती है, then it will reflect back through the focus of the mirror. But if it comes on the convex, अगर वो convex पे आती है, then it will reflect back to the other side. Means वो दूसरे तरफ डेविएट हो जाएगा, उसको दूसरी तरफ डाइवर्ट हो जाएगी, जिसको कि हम लोग बाद में अपेयर कर सकते हैं पीछे फोकस की तरफ। ओके, so this thing you need to remember. Once again, for a concave mirror, when the light ray is coming parallel to the principal axis, when it is coming parallel to the principal axis, it will reflect back through the focus of the mirror. And when it is coming on the convex mirror, then it will reflect back to the other side. Means वो deviate हो जाएगी, वो दूसरे तरफ भाग जाएगी और उसको appear करना पड़ेगा पीछे की तरफ meet करने के लिए। The second case, the second condition which we need to understand, just the reverse of the first one. First one का reverse. If the light ray is coming through the focus, अगर concave में देखते हैं कि if the light ray is coming through the focus, then it will reflect back by forming parallel to the principal axis. अगर light ray focus से cross होती है, then it will become parallel to the principal axis. वो principal axis के parallel हो जाएगा। और convex में हम क्या बोलेंगे? If it is coming on the path of focus, I will not say that it is coming to focus or it is coming through the focus. I will say that it is, if it is coming on the path of focus, then it will reflect in such a way that it will become parallel to the principal axis. Okay, so you need to understand the concept, as well as you need to remember the principle which is going to form over here. The next thing which we have to see over here, that the third rule, if the light ray falls on the pole of the mirror in such a way that the principal axis is the normal. ये ध्यान देना कि यहाँ पर अगर हम लोग देखते हैं कि लाइट रे इस तरह से पोल पर गिर रही है मिरर के, जहां पर कि प्रिंसिपल एक्सिस हम लोगों के लिए नॉर्मल है, then the light ray will reflect to the other side. Okay, and over here both the angles will be equal. Okay, which is again the principle or the law of the reflection. Now the next thing is that if the light ray is coming on a convex mirror in the same situation, then it will reflect back like this and the angles will forming over here. So this is also same what we had done in the concave. Now one thing, before I go for the another point, sometimes students do ask, so do whether over here the light ray is following the law of reflection or not? Yes, it is following. If you will draw a normal over here or over here, or at this particular point, or at this particular point, you will observe the law of reflection has been followed. Here also this angle and this angle will be equal. This is the angle of incidence and this is the angle of reflection. Over here, these two will be equal. Here also, this is the angle of incidence and this is the angle of reflection. They will be equal. At every situation, here this line should be like this, a little bit like this. So here angle of incidence will be this and angle of reflection will be this. They will be equal. So at every situation, the law of reflection has been followed. It's not that at this situation, we will not observe the reflection of light has been not be followed. Okay. Now, the last condition, excuse me, students. Okay. So the last condition which we need to understand over here, that if the light ray is coming through the optical center of the mirror, अगर लाइट रे जो है वो ऑप्टिकल सेंटर से होते हुए क्रॉस करती है, then for a concave mirror it will reflect back with the same path. It is going to reflect back with the same path. Okay, so over here the angle of reflection will become 0. The angle of reflection and angle of incidence will be considered to be as 0. In the same way, if the light ray is coming on the path of optical center on a convex mirror, then it is going to reflect back again on the same path. So over here also the angle of incidence and angle of reflection will be considered to be as 0, which we had studied in a plane mirror. For a plane mirror, we know this thing, that if the light ray is falling perpendicularly, if the light ray falls perpendicularly, then what happens? We know for this thing that if the light ray is coming perpendicular, then it is going to reflect back also perpendicular. So this phenomena we had studied earlier also. And because of this particular phenomena, we used to say this thing, that here also, that when the light ray is coming through the optical center through a concave mirror, or when we observe that the light ray is coming in the path of a convex mirror, in both the situation we will observe this thing, that the angle of incidence is equals to the angle of reflection, where that will be 0 degree. So is it clear to everyone? Have you all understood this particular concept? Is there any doubt or any problem in the rules of the image formation? Yes, students, do anyone is having any problem?
Sir.
Yes.
Sir, can you repeat what you have said about the incident and the reflected ray in the examples of the concave and the convex mirror? Sir, I was disconnected.
Oh, pardon. Can you please repeat which one you want to know? Again, I will tell.
So that the questions which are asked by the students often. That's
okay,
why.
okay. For that one. Okay, again, I'm telling. So as I was saying, that sometimes students used to ask this thing, that under this kind of situation or this kind of situation, when I say that the light ray is coming parallel to the principal axis and the light ray reflects back through the focus. So at all for these conditions, do the law of reflection been followed? Which law of reflection? किस law of reflection के बारे में बात कर रहे हैं? हम लोगों ने पढ़ा हुआ है कि एंगल I is equals to एंगल R. तो हम लोग प्लेन मिरर के बारे में तो ये सीधे सीधे कह देते हैं कि प्लेन मिरर पे जब लाइट रे इस तरह से आती है, वो रिफ्लेक्ट कर जाती है बीच में नॉर्मल के साथ. एंगल ऑफ इंसिडेंस और एंगल ऑफ रिफ्लेक्शन बोथ आर इक्वल. एंगल ऑफ इंसिडेंस इज इक्वल्स टू एंगल ऑफ रिफ्लेक्शन. लेकिन क्या वही प्रिंसिपल यहाँ पर भी अप्लाई होती है? यस, दैट यूज्ड टू बी अप्लाइड ओवर हियर. अगर तुम यहाँ पर एक नॉर्मल कंस्ट्रक्ट करो, यहाँ पर तुम अगर एक नॉर्मल यानी परपेंडिकुलर कंस्ट्रक्ट करो, या फिर यहाँ पे तुम एक नॉर्मल कंस्ट्रक्ट करो, सो इन बोथ द सिचुएशन you will observe that the angle of incidence is this and angle of reflection is this, and both the angles will be equal. Angle of incidence and angle of reflection will be equal. And not only in this one, in this situation, in this case, every time it will be equal. At every case it will be equal, such as over here also the theta which has been formed, both the angles will be equal over here. So that is the thing which I was explaining over there. Is it clear?
Yes, sir. Thank you, sir.
Yes. Anything else? Anyone? Anything else till here? यहाँ तक कहीं पे कोई doubt, कहीं पे कोई भी confusion हो तो पूछो. Yes, students? No? Okay. So then we can move to the next one. Here we have to see for the image formation. So how do the image used to form? So we have to go for the image formation by concave and convex mirrors. So there are 6 image formation by concave mirrors and 2 image formation by a concave mirror. So here are the image formations which you can see over here, and you need to practice them. Okay, if you are not practicing the image formations, there will be problem. Each one of you have to practice all the image formations, as well as you need to remember the characters of the image which has been formed over there. अगर ये भी याद नहीं है तो भी प्रॉब्लम हो जाएगा. क्यों प्रॉब्लम हो जाएगा? सबसे बड़ी प्रॉब्लम तो हो जाएगी तुम लोगों को न्यूमेरिकल्स सॉल्व करने में. For the case of the solving of the numericals, you need to remember these properties. अगर ये properties याद नहीं रहेगा तो बहुत सारे न्यूमेरिकल्स को बनाने में तुम लोगों को प्रॉब्लम होगी. तो अगर न्यूमेरिकल्स को अच्छे से बनाना है, अगर न्यूमेरिकल्स को अच्छे से सॉल्व करना है, then you have to remember the property with the formation of the image. Okay, so what they are and how they are, let's understand and see for that one. So over here in this first page, I'm going to discuss for the 4 image formations. The first image formation is for concave mirror. So concave mirror का first image formation है when the object is placed at infinity. Infinity means over here that the object has been placed in front of the mirror at a distance which is unknown to us. यहाँ पर infinity का मतलब है कि मिरर के सामने में है, लेकिन हमको उसका डिस्टेंस एग्जैक्टली नहीं पता है, हमको उसके बारे में नहीं पता कि वो कितनी दूरी पर है, वो उसके उससे 10 मीटर की दूरी पर हो सकता है, 100 मीटर की दूरी पर हो सकता है, डिपेंडिंग ऑन द सिचुएशन, बट आई डोंट नो इट्स एग्जैक्ट पोजीशन. Okay, so for that situation, what would be the image formation? Here I had used this image so that you can see the size of the image. Okay, because the object is the object has been placed very much far away from the mirror at infinity, and its image has been formed this one. You can use another image formation. So like this, suppose for example the light ray is coming like this, parallel, as the object is not known to us, so we don't know its exact position. So when the light ray is coming parallel to the principal axis, it will be reflecting through the focus. हम लोगों को पता है कि वो फोकस से इस तरह से रिफ्लेक्ट कर जाएगा. चूंकि हम लोगों ने पहले ही प्रॉपर्टी पढ़ा हुआ है, उसी प्रॉपर्टी के बेसिस पर यहाँ पर हम लोग देख सकते हैं. तो जब लाइट रे यहाँ पर आती है, इस तरह से पैरेलल आ रही है, इट विल बी रिफ्लेक्टिंग बैक थ्रू द फोकस. वो रिफ्लेक्ट कर जाएगा फोकस के थ्रू. तो यहां पर जब वो रिफ्लेक्ट कर रहा है फोकस के थ्रू, दिस इज द फोकस, आवर इमेज इज गोइंग टू फॉर्म एट फोकस. ओके, द इमेज इज गोइंग टू फॉर्म एट फोकस ओनली, वेयर इट इज गोइंग टू बी रियल, इन्वर्टेड एंड हाईली डिमिनिस्ड. ठीक है, तो यहाँ पे तो डिमिनिस्ड इमेज बन रहा है, लेकिन हम यहाँ पे जो तुम लोगों को फिगर में दिए हुए ये इमेज इसीलिए दे रहे हैं ताकि तुम लोगों को दिखे कि हाँ इमेज बनता है. ठीक है, वो काफी छोटा हो रहा है. अगर हम देखें, इसका कंपैरिजन करें, तो जो सामने ऑब्जेक्ट रखा हुआ होगा वो काफी बड़ा होगा, उसके कंपैरिजन में ये जो इमेज बन रहा है वो काफी छोटा है. इसी चीज को ये डिनोट कर रहा है. सो ओवर हियर व्हेन द ऑब्जेक्ट इज प्लेस्ड इन फ्रंट ऑफ अ कॉन्केव मिरर at infinity, then the image is going to form at focus, which will be real, inverted and very small in size. It is going to be very, very small in size. So that is the first condition. Okay, the second situation, चलो second situation में देखते हैं कि कैसे image बन सकती है. So when the object is placed in front of the concave mirror, and over here we have the position, we can say this thing that the image, the object has been placed beyond C. You can see over here it has been placed beyond C. तो C के पीछे, तो हम लोग determine कर लेते हैं, say as for example this is focus and say as this is the center of curvature, and over here the object has been placed. So when the object has been placed over here, the very first light ray will be parallel to the principal axis. ओके, ये प्रिंसिपल एक्सिस के पैरेलल होगा एंड इट विल रिफ्लेक्ट बैक थ्रू द फोकस. वो फोकस से रिफ्लेक्ट कर जाएगा. एंड द सेकंड रे आई कैन पास इट फ्रॉम द सेंटर ऑफ कर्वेचर. हम सेंटर ऑफ कर्वेचर से क्रॉस करवा सकते हैं. तो ये लाइट रे की पाथ इधर से इधर आ गई और इस लाइट रे की पाथ इधर से इधर ही चली जाएगी, क्योंकि हम लोगों ने रूल पढ़ा हुआ है कि इफ द लाइट रे इज कमिंग थ्रू द सेंटर ऑफ कर्वेचर, इट इज गोइंग टू रिटर्न बैक और रिफ्लेक्ट बैक थ्रू द सेंटर ऑफ कर्वेचर ओनली. Then our image is going to form somewhere between the F and C. Okay, and students, please remember to put all these arrows. These arrows are very, very important. Okay, don't miss any of the arrows. अगर arrow miss कर जाओगे, figure wrong हो गया. Figure wrong हो गया, क्योंकि you have to show that the path of the light ray. तुमको दिखाना है कि light ray का path क्या है. So this is very, very important. So when the object is placed beyond C, जब C के पीछे object रखा जाता है, then the image is going to form somewhere between the C and F, where it is going to be real, inverted and smaller in size. Diminished means smaller in size. So again, when the object is placed beyond C, then the image is forming between C and F, where it is going to be real, inverted and smaller in size. So I hope that you all had understood this particular concept also. Now, let's move to the next condition where we are going to understand when the object is going to place little bit in different condition. So here I'm going to place the object between, not between, at C. At C, okay? At C only I will keep the object, okay? So what is going to happen over here? We will see this thing that the light ray which is coming parallel to the principal axis, it will reflect back through the focus. It is going to reflect back through the focus like this. And the second light ray, I'm allowing it to come through the focus only. Okay, it is coming through the focus. And so just a minute, I will just arrange it in a little bit good way. Like this, okay, like this it is there. So I'm not using a proper scale, hence it is not coming in a right manner. When you all will draw with a proper scale, it will come in a correct way. Okay, and this is going to reflect back by forming parallel to the principal axis. Please remember the rules which we had done. So according to the rules only, we will go for the image formation. So it is going to be parallel to the principal axis like this. And when it is going to be like that, then our image is going to form at C only. Okay, so here when the object is placed at C, then its image is going to form at C, where it will be real, inverted, of the same size to the object. यानी यहाँ पे जो image बनेगा वो real होगा, वो inverted होगा और वो same size होगा to the object. Okay, so I hope that you all had understood till here. Is there any confusion till here? कहीं पे कोई doubt? यहाँ तक के image formation में अगर कहीं पे कोई doubt है तो तुम लोग पूछ सकते हो. Is there any problem? No? So could we move to the next one? Okay, so let's see for the fourth condition. Now we are taking the object little bit closer to the mirror. अब हम लोग mirror के थोड़ा सा और नजदीक लेके चले जाते हैं. So I am taking the object between C and F. I am keeping the object between C and F. So over here, I will observe that the first light ray, which is going to be parallel to the principal axis, it will be coming through the focus. It is going to reflect back through the focus. And the second light ray, I'm allowing it to pass through again through the focus. If I will allow it through the focus, then what will happen? It is going to reflect back. So I will adjust it a little bit over here. Okay. So, and when this light ray is going to reflect back, it is going to bounce back, or it is going to reflect by forming parallel to the principal axis. So when it is parallel to the principal axis, then our image which is going to form, it is going to form beyond C, where it is going to be real, inverted, and larger in size. Okay. So again, remember the characters of the image formed. So if the object is placed between C and F, then the image is going to form beyond C, where it is going to be real, inverted, and larger in size. Please, again and again, I'm reminding this thing. You have to learn the properties. अगर तुम लोगों को प्रॉपर्टीज याद नहीं रहेंगी तो तुम लोगों को इमेज बनाने में भी प्रॉब्लम होगा, और साथ ही साथ जो सबसे बड़ी प्रॉब्लम होगी न्यूमेरिकल्स बनाने में. तो न्यूमेरिकल्स को बनाने के लिए तुम लोगों को इमेज के प्रॉपर्टीज जानना ही है. तो अगर वहां पे डाउट होगी या वहां पे कुछ प्रॉब्लम रहेंगे, then there will be very big problem. So again and again I'm repeating, you practice these images. सभी images को practice करो. कहीं पे डाउट है, कहीं पे कुछ प्रॉब्लम है, you ask. You feel free to ask me. Again, I will repeat. I have no problem for that one. Okay, but you need to practice the images as well as you need to remember the properties. ठीक है? तो ये थे पहले 4 images which can be formed by a concave mirror. Then we are moving to the last 2 images of a concave mirror, and then we will come to the 2 images of concave mirror. Sorry, yes, Sneha, say. बोलो
सर. पोजीशन ऑफ ऑब्जेक्ट सिमेट्रिक है या एसिमेट्रिक है, वो कैसे पता लगेगा?
देखो, यहाँ पे सिमेट्रिकल कंडीशन हम लोग नहीं ले रहे हैं. यहाँ पर हम लोग कंडीशन ले रहे हैं प्रिंसिपल एक्सिस के बेसिस पर. देखो, जब हम एक मिरर लेते हैं, सपोज फॉर एग्जांपल हम यहाँ पर एक मिरर लिए हैं, से एज दिस इज अ कॉनकेव मिरर. अब मेरा प्रिंसिपल एक्सिस कहाँ पर है? हम प्रिंसिपल एक्सिस को कैसे ड्रॉ कर रहे हैं या किस जगह पे ड्रॉ कर रहे हैं, इसके ऊपर डिपेंड कर रहा है। तो मेरा प्रिंसिपल एक्सिस यहाँ पे भी हो सकता है, मेरा प्रिंसिपल एक्सिस यहाँ पर भी हो सकता है, मेरा प्रिंसिपल एक्सिस यहाँ पर भी हो सकता है, या मेरा प्रिंसिपल एक्सिस यहाँ पर भी हो सकता है। तो हम लोग जनरली जब इमेज फॉर्मेशन को करते हैं, जब हम लोग इमेज फॉर्मेशंस को पढ़ते हैं, तब उस दौरान हम लोग प्रिंसिपल एक्सिस को मिरर के सेंटर पर ही ड्रॉ करते हैं। तो उसी के हिसाब से हम लोगों का इमेज जो है वो वहां पर कंस्ट्रक्ट कर पाते हैं, या फिर जो डायग्राम है, जो हम लोग के इमेज फॉर्मेशन का जो डायग्राम है, उसको हम लोग बना पाते हैं। तो यहाँ पर हम लोगों का सिमेट्रिकल या असिमेट्रिकल सिचुएशन से कोई लेना देना नहीं है। ठीक है, इज इट ओके?
Yes, sir.
Okay, so now let's move to the next condition. Over here we are going to discuss about the image formation by a concave mirror when the object is going to place little bit closer over here. अब हम लोग इमेज ऑब्जेक्ट को थोड़ा सा और नजदीक लेकर चले आते हैं। So suppose this is our focus and this is our center of curvature. Students, I will give you a trick. जब तुम लोग कॉपी में बनाओगे फिगर को, तो ये याद रखना, तुम लोग जब स्केल से लाइनिंग ड्रॉ करोगे, तो जो फोकस का लेंथ लोगे पोल से, जैसे ये पोल है, तो सपोज फॉर एग्जांपल तुम लोगों ने 2 सेंटीमीटर लिया, सपोज 2 सेंटीमीटर लिया, तो ध्यान रखना कि पोल से जो सेंटर ऑफ कर्वेचर की जो डिस्टेंस है वो 4 सेंटीमीटर ले लो। ठीक है, तो ये तुम्हारे ऊपर डिपेंड करती है। इफ यू वांट टू इंक्रीज और डिक्रीज द वैल्यू, इट इज ओके, बट आई वांट टू से दैट यू जस्ट मेजर इट एंड देन प्लेस द पॉइंट ऑफ सी एंड एफ। सी और एफ को मेजर करके प्लेस करना, तो इससे तुम लोगों के लिए इजी हो जाएगा फिगर को ड्रॉ करना। एंड अगेन आई एम रिपीटिंग, यू नीड टू प्रैक्टिस ऑल दीज इमेजेस. No one will leave it out. Please practice that. Okay. Now, over here, I'm going to take the object between C and F. तो हम लोग नहीं, between C and F तो हम लोग कर चुके हैं। तो अब हम लोग कहाँ पे लेके जाएंगे? We are moving the object to focus. अब हम लोग focus पे लेके चले जाते हैं object को. So if the object has been taken to the focus, then what is going to happen? See, the light ray which is going to be parallel to the principal axis, it is going to reflect back through the focus. And the second light ray, which is going to come in the path of the center of curvature, it is going to reflect in the same path only. ये center of curvature के path पे चले जाएगा। मेरा पॉइंट यहाँ पे एग्जैक्ट मैच नहीं कर रहा है, बट व्हेन यू विल डू इन योर कॉपी इन अ प्रॉपर मेजरमेंट, you will see that it will be correctly coming over there. So they will become parallel, means these two light rays will become parallel. ये दोनों ही reflected light rays जो हैं, ये यहाँ पे parallel हो जाएंगे. So when they are forming parallel, as we know for this thing that two parallel lines never used to meet each other, so the image is not going to form. So we assume, we say that if they will meet at any point, even though we know that the parallel lines never meet each other, but if they meet at any point, then they will form, or it will form, a real image, an inverted image, and the image will be very much enlarged. Okay, यानी जो size of the image होगा वो बड़ा होगा. It will be real, inverted, and very large in size. Okay, so these properties which I had given already over here, so that is present. Now let's move to the last image formation for the concave mirror. तो concave mirror के लिए last image formation हम लोग देखते हैं. So this is the concave mirror, and over here let's see for the object when it is been placed very much closer over here. तो अगर हम लोग ऑब्जेक्ट को और क्लोजर लेके चले आते हैं, तब वहां पर किस तरह का इमेज फॉर्मेशन होगा. So say as this is the focus and this is the center of curvature. Now if I will keep the object between F and pole, अगर हम ऑब्जेक्ट को F and pole के बीच में रखते हैं, then what is going to happen over here? We will see the first light ray which is going to be parallel to the principal axis, जो यहाँ पर principal axis के parallel आएगी, it will reflect back through the focus. वो focus से reflect back कर जाएगी. ठीक है, और यहाँ पे देखोगे कि ये लाइट रे चूंकि पीछे की ये यहाँ रिफ्लेक्ट कर रही है, तो हमको यहाँ पे पीछे प्रोड्यूस करना पड़ेगा, क्योंकि इट इज नॉट गोइंग टू मीट इट इन अ प्रॉपर वे. सो आई हैव टू प्रोड्यूस दिस लाइट रे. Now again, the second light ray which is going to be there, that is going to be like this. So it is going to come in the path of the center of curvature, and it is going to be like this. It is like this. Just a minute, I have to rearrange it like this. Now यहाँ पर भी ये दोनों जो है ये रिफ्लेक्ट कर गए, और यहाँ पे देखोगे कि ये दोनों लाइट रेज जो हैं, ये दोनों ही लाइट रेज जो हैं एक दूसरे से अपार्ट है, ये दोनों लाइट रेज एक दूसरे से अपार्ट है. So I can produce this one also at the back side. So when I will produce this, I will obtain an image which is going to form over here. यहाँ पर एक इमेज बन रही है मेरे लिए. तो ये जो इमेज यहाँ पे बन रहा है, this is a virtual image. Remember this thing. This is a virtual image, and this is forming behind the mirror when the object is placed between F and pole, where the image is forming. Again, I'm repeating, where the image is forming behind the mirror. It will be virtual, it will be erect, okay, and it will be larger in size. It is going to be comparatively larger than to the object which we are using over there. Is it clear to each and everyone? Have you all understood till here? Is there any doubt? यहाँ तक में कहीं पे कोई भी doubt है तो पूछ सकते हो. Yes?
Sir,
Yes.
Sir, convex और concave mirror का जो reflection है वो irregular हुआ?
नहीं, दोनों ही रेगुलर रिफ्लेक्शन है. दोनों ही, चाहे वो कॉनकेव के लिए बात करें या कॉन्वेक्स के लिए बात करें, दोनों ही रेगुलर रिफ्लेक्शन करेगा, क्योंकि मिरर है तो स्मूथ सरफेस होगा, और अगर स्मूथ सरफेस है देन देयर विल बी अ प्रॉपर इवन रिफ्लेक्शन. इज इट ओके?
तो सर रेगुलर रिफ्लेक्शन और इरेगुलर रिफ्लेक्शन ऑब्जेक्ट का साइज पे डिपेंड नहीं करता है कि कैसा ऑब्जेक्ट का साइज होगा रिफ्लेक्ट करने के बाद?
नहीं, रेगुलर और इरेगुलर रिफ्लेक्शन जो है वो सिर्फ और सिर्फ सरफेस के बिहेवियर के ऊपर डिपेंड करता है. सरफेस कैसा है, अगर सरफेस स्मूथ है तब कोई प्रॉब्लम नहीं है, लेकिन अगर सरफेस स्मूथ नहीं है तब वहां पर प्रॉब्लम होगी, यानी वो उसके रेगुलर या इरेगुलर होने के चांसेस हैं. नहीं तो जो मिरर्स हम लोग यूज करेंगे, जो भी प्लेन मिरर यूज कर रहे हैं या स्फेरिकल मिरर यूज कर रहे हैं, उसमें ऑब्जेक्ट से रिलेटेड कोई भी प्रॉब्लम नहीं आएगी. वॉट एवर काइंड ऑफ ऑब्जेक्ट वी आर यूजिंग, इट विल फॉर्म अ प्रॉपर रेगुलर इमेजेस ओनली. ओके, इज इट क्लियर?
यस
ओके. चलो ठीक है, अब हम लोग जल्दी से लास्ट के दो इमेज फॉर्मेशन देख लेते हैं विच इज रिलेटेड टू द कॉन्वेक्स मिरर. तो कॉन्वेक्स मिरर के दो ही इमेज फॉर्मेशंस हैं, और इसमें से जो सेकंड इमेज फॉर्मेशन है वो ज्यादा इंपॉर्टेंट है हम लोगों के लिए. द फर्स्ट वन वी हैड ऑलरेडी डिस्कस्ड व्हाइल वी वर डिस्कसिंग अबाउट दैट द कॉन्वेक्स मिरर्स आर आल्सो नोन एज अ डाइवर्जिंग मिरर. जहां पर हम लोग ये डिस्कस कर रहे थे कि कॉन्वेक्स मिरर डाइवर्जिंग मिरर होती है, तो उसके प्रॉपर्टी में हम लोगों ने पहले कंडीशन को समझ लिया था. So what is that? That is when the light ray is coming parallel to the principal axis, means for the object which is placed at infinity. Again, any object which is placed at infinity, I don't know its exact position where the object has been placed. I don't know its exact position. So for that one, when the light rays are coming parallel to the principal axis, जब light ray parallel आ रही है principal axis के, it will reflect back to the other side. वो दूसरे साइड वो रिफ्लेक्ट कर जाता है, यानी वो डेविएट कर देता है, उसको डाइवर्स कर देता है. और जब इसको ये डाइवर्स कर देता है, then we need to produce them. तब हम लोगों को यहाँ पर इसको पीछे प्रोड्यूस करनी पड़ती है. तो जब हम लोग इसे पीछे प्रोड्यूस कर रहे हैं टू मीट इट एट द फोकस, देन द इमेज इज गोइंग टू फॉर्म एट फोकस. तब यहाँ पर इमेज जो है वो फोकस पे फॉर्म होता है, वेयर इट इज गोइंग टू बी वर्चुअल, इरेक्ट एंड वेरी स्मॉल इन साइज. मींस द इमेज इज गोइंग टू बी वर्चुअल, इरेक्ट एंड very small in size. So you need to remember this thing. So once again, when the object is placed in front of a convex mirror at infinity, then its image is going to form to the other side of the mirror, where it is going to be virtual, erect and very small in size. Now the second and the last image formation for the convex mirror, when the object is placed in front of the mirror anywhere. अब ये ध्यान देना, कॉन्वेक्स मिरर के सामने हम कहीं पे भी ऑब्जेक्ट रखें, हम उस ऑब्जेक्ट को कहीं पर भी रखते हैं, then we will observe that the image is going to form in the same pattern. I will not say of the same size, but the same pattern will be followed. Either I am bringing it little closer, taking a little far away, or a little more far away. At all the situation, my images will be in the same pattern. So over here, when the object is placed like this, then the image which is going to form it is like this. So the first light ray will be parallel to the principal axis. Just a minute. Okay, here. The first light ray will be parallel to the principal axis. And as it is parallel, it will reflect back to the other side. It gets bounced back to the other side. So I will produce this one to the back side. I'm going to produce it over here. When I'm going to produce it like this, then it is meeting at focus over here. And the second light ray which I'm going to take, that I will take in the path of the center of curvature. To the path of the center of curvature I will take. And when I will produce it further, when I'm going to produce it further, I will observe that it is going to meet at center of curvature, because we know this thing that when the light ray is coming in the path of center of curvature, then it crosses through the center of curvature. So it's reflect back in the center of curvature's path. So you can see that these two light rays are intersecting at this point. Okay, so which is between pole and the focus, between pole and focus. So whenever the object is placed in front of a concave mirror, anywhere, again I'm mentioning this thing, repeating this thing, that when the object is placed in front of a convex mirror at any position instead of infinity, then its image will always form to the other side of the mirror between pole and focus, where the image is going to be virtual. It is going to be virtual, smaller in size and erect. Okay, it will be virtual, erect and smaller in size. So these are the characters which you need to remember with the image formation. So I hope that you all will practice all these things, and you had understood all these points over here. And if there is any doubt or any problem, you mark it. We will discuss it in our next class. And in next class, we are going to understand about the sign convention. And with that one, we will also understand about the mirror formula and how we can calculate the different things with mirror formula. So that is the most important thing of this particular chapter. So sign convention is very, very important. With sign convention only, you will be able to use the formula to calculate the things which has to be done over there. So I'm keeping today's class till here only. We will meet again in our next class, and in that class we will discuss more on this mirror formula, sign convention, and the numericals, how we can do that. Okay, so all of you please revise till here. Thank you everyone. Bye.